we're not at our, we don't have a threshold of 2 millivolts, then it becomes unpredictable. So our output is just going to be a big question mark. It's unreliable. Right.
So then, Kurt, when you do the V out, you just want to put plus or minus 13?
Yep, you're going to just do the plus or minus 13. Yep. Yep, and that's exactly how you'd write it. Because we know that it's going to go to 90% of VCC. So yeah, you're going to either plus or minus 13.5. What you're really actually going to find out is that I think it typically is the always, I think it goes more positive than it does more negative. So the chances of most of your guys are all going to, I think, go more positive, 13.5 volts. But for estimates, for the ideal op amp, we just say unpredictable, 13 plus or minus 13.5 volts. 90% of our VCC. So if I had 10 volts, it would be 9 volts, plus or minus 9 volts. So it's always 90% of your VCC. All right. What happened to her? Oh, she must have left her tripod at home. She borrowed it last weekend.
She's got one.
Yeah.
That'll teach her a lesson. This is your lesson, Volkai. Don't sit next to Mindy.
Or yeah.
Oh, you want your phone back? That's going to cost you.
Yeah.
So it doesn't
Break
matter.
already.
It doesn't matter what you put into this thing.
It's Wednesday.
Kurt, you're always going to get 13 and a half on it. There's the point of average. It's important.
Okay, that's going to be my next thing here. So I'm going to erase this here. So the most simple way is, the most simplest form, now it's not, there's a little bit more circuitry to it, but the most practical application of this is, what I'm going to do is I'm going to have this board on there, and then there's going to be a plate on here. So here's my board, I'm going to have a plate on here. And this plate's going to pivot right on that spot. And it's going to be hooked up to another motor. Okay, and it's kind of driving on a chain here. On this plate, with this divider on there, we can have like our solar panels. Okay? And then on our solar panels, then there's going to be two sensors. It's going to be our light sensors. So what we're going to be taking a look at is that we want to be able to track the sun. So here's my sun. So my sun is off a little bit off to the right. Well, what's going to happen is that this photocell, and I can maybe remember we use those on the very, like on chapter 4 there, we used our photocell. This will be our output. Okay? So that photocell was a photoresistant type cell and stuff that changes resistance as it's seen more light. And so this voltage, you know, depending on how much light it had, it's going to create a voltage divider, and that output voltage is going to go either up or down. So what we're doing is we're taking two of these photocells, and what we're going to do is that when it starts seeing the sun, what's going to happen is that each one of these cells, so here's B in from our one sensor and then B in from our other sensor. So what's going to happen is that it's going to do a comparison. What's going to happen is that this photocell here is going to become more conductive or less conductive, or it's going to, I should say this one, well, I'll just say this one here is going to become more conductive. The voltages on this one is going to start dropping down. So we'll say this one is our B2 and this is our B1. So the voltage drop across our photocell on this one is going to be less, and our voltage is going to start to go down. So my voltage on here is going to start to go down. This one's going to be, we'll just say, we'll say that this one here is
Negative.
seeing a voltage drop of plus 1 volt. V1 isn't seeing so much light because it's got this plate on here, so it's kind of in the shadow of it. So this one's going to have more resistance, and it's going to have a higher voltage drop. And so V1 is going to have a higher voltage, and we'll say that it might be at plus 3 volts. So what it's going to do is it's going to compare, it's going to see that there's a 2 volt difference. It's going to multiply it by our gain of 100,000, so it's going to give us approximately 200,000 volts. That's what I'd like to try and get to, but it knows that it's only going to get to VCC. So it's going to go to our inverting one, our non-inverting one is more positive. It's going to be a non-inverting signal, and it's going to put out 13.5 volts. So what happens is that 13.5 volts is going to go into our motor, give us a 13.5 volts, we'll just say it's a 13.5 volts motor, and it's going to start turning that motor. And what's going to happen is that motor is going to start to turn. And then eventually it's going to meet to where V1 and V2 are equal in voltage. Now, we know that on an open loop comparator like this, what it's going to do is it's going to sit there, and V1 and V2 are going to be real close. So we'll just say that this one's at plus 2 volts now, and this one's at plus 2 volts. And what it's going to do is it's going to sit there, and once they even out, if it keeps on going a little bit more, then V2 is going to have more voltage. So then it's going to want to go to a negative saturation, and it's going to try moving the motor backwards. And so what it's going to do is it's going to sit there and oscillate right at the sun. And so that's why we're using like comparators. That's about the easiest way to really actually see what we're doing. We're taking two signals and we're comparing it. It's going to bring it until they equal, and then it'll just sit there, and it'll kind of just sit there and hum. And then as that sun starts to set, then it's just going to keep on tracking it. It's just going to sit there and oscillate right at, so that always is following the sun. So that's why if we had big solar panels in there, we're maximizing the amount of sun that we have going onto our solar panels, and it'll just automatically track the sun. The next morning, the sun starts to rise, it all tilts back over there, and then starts following the sun all throughout the day and stuff. So that's why we're doing, that's why we use comparators. We're always kind of comparing the signals, what is it, and we're kind of controlling our motors or our drives or something depending on what it is. Another application is what we call like web processes, like newspaper machines and stuff like that. We're trying to maintain a certain constant pressure on the web and stuff, and we'll use comparators in there. So comparators get to be used all over the place. And this is about the most simple application that you can see to get a good visual picture. But we're just comparing two signals so that we can regulate something. All right. So any questions on the open loop comparator? All right. Well, we'll move on to the next one. We'll take Brent decided to take up smoking, so he wants to have a cigarette, so he's going to go out and...
Yeah.
No, okay. All right, so let's take a 10